Okay, so it's my understanding, well, actually, let me start with two things. Is Ed here, Ed Mast? So for the FreeBSD folks in the room, I would highly recommend watching his talk yesterday about Git versus SVN. To me, personally, it's really exciting to see a community kind of objectively evaluating large changes like this, and personally, I'm a longtime Git user, and I think it's a great version control system. So anyway, I would really like people to kind of evaluate that, not for my sake or anything, but just because I think it's cool that the community's doing this. And the other thing is, my understanding is, and feel free to correct me if I'm wrong, there hasn't been a lot of Intel talks here. I know Jeff, I was talking to at dinner last night, did one on networking a couple years ago, but for the most part, there hasn't been much presence. So I was going to start off with a little bit of an introduction about myself and Intel, assuming that people don't know that, but I can skip over that if my history is wrong. No? Okay. And finally, I'm more than happy to take questions at any time. I very much like the style of interaction, so mics are over there. I'd like people to remember that I work for a very large company and I'm an individual, and I'll do my best to say when things are Intel and when things are me, but if there's any ambiguity, just go ahead and go to the mic and feel free to ask and I'll clarify. So we're going to talk about some of the past involvement that I'm aware of. That should be pretty quick. It's mostly just a history lesson. We're going to talk about what we're doing today, what myself and Scott in the room are actively working on, what some of the networking folks are working on, and that. We're going to talk about what I would like to do next. And then if there's time, and I think there will be, we're going to talk about specifically what I'm doing in power management right now, where I'm stuck, where I need help, where I'd like to go, how it should work. That would be a little bit more on the technical side. So I hope to have time. And then Q&A. So I'm sort of interesting at Intel. At least I haven't found too many people like me. I think I have a laser pointer. So I actually got introduced to FreeBSD in 2003. I had a professor at my university, Ken Smith, who was a release engineer for the FreeBSD project, and he taught a class on advanced operating systems, and all the projects that we did were FreeBSD based. So we did access control lists. That was the final project I remember. And he was an active member in the community, and he really spoke highly of FreeBSD, even though we were using FreeBSD 5, which I understand was not one of the prouder releases for FreeBSD. It booted. So I've been at Intel since 2005. There's a little interesting period here where you guys might be looking at. So I worked on the Larrabee project, which for those of you in the room that are unfamiliar was a discrete graphics card that Intel tried to make with a bunch of x86 cores. We weren't very friendly to the community. I joined that project, by the way, like, I'm not guilty here. I joined that project after they had already decided this, and they had picked FreeBSD, and they had decided we weren't allowed to interact with the community. I got special permission, I don't know if you can find it on Google, in like 2008 I found a bug in ptrace, and I got special permission to like post to the mailing list my question, and it was summarily dismissed by someone named Gary Jenajon. I don't know who that is, but I think he was wrong, by the way. So I'm a longtime graphics developer. I did Linux graphics driver development. I started in 2010 on the i9-15 driver. I did a lot of the memory management. Did I cut out? Oh, I did a lot of the memory management for that. If people are interested, by the way, I have a series of blog posts about how memory management in i9-15 works. I've gotten a lot of feedback that they're quite good. And so if you're interested, I would advise you to look at those. I took a lot of care in that. I went on to become a user space graphics driver developer, so there's kind of a big difference in graphics between kernel mode driver and user mode driver. Unlike a lot of other hardware, the user mode does a lot of the actual hardware-specific command submission, and the hardware, or the kernel driver kind of, maybe oversimplifying it, but it does the dispatch to the hardware, and it's a it's a very complex and interesting project. That's the Mesa 3D project. And finally, I became the graphics architect for our Linux graphics driver, both user space and kernel mode. And to be clear, in this period over here, I found out about this opportunity. A new group was starting up, and I found out about it, and it was really exciting. And so I voluntarily left, in case people are curious. I voluntarily left doing my graphics work to take this opportunity doing general FreeBSD enabling. So for those of you who are unaware of the OTC, which I'm assuming is probably a lot of you, the OTC is a group within Intel, Open Source Technology Center. They are part of SSG, which I think is the Software and Services or Solutions group. It's a fairly large chunk of Intel. The OTC itself is obviously a subset of that. We have quite a long track record of contributing to open source. However, when I say open source there, I really mean Linux for the most part. We employ the other Alan Cox, and we have a lot of people. I know there's some Linux users in the room, but there's quite a lot of people who have been very established and long-time Linux developers that work for us. So Andy Clean, for instance, who was the original maintainer of the x86-64 part of Linux kernel. There's a site here that has a list of all the projects that currently Intel contributes to. A lot of those projects, not a lot, but a good chunk of those projects were actually projects that Intel founded and then ended up giving to the Linux Foundation or some other entity. I was kind of asked to talk a little bit about this for the folks in the room who maybe aren't used to contributing to permissive or open source licensed projects. Our policy at Intel generally is to match the ecosystem. So fundamentally, we sell silicon, and the job from software is to do enabling so that people can use that silicon. And if there's an existing project, it's pretty straightforward. We take whatever they're doing and we do the same. And like I said, OTC has pretty much been Linux focused till now, and so, excuse me, that meant GPL 2 or 3 for the most part. And with this big push to everything in the cloud, Apache 2 has become sort of the license du jour. Oops. So that sort of brings an interesting problem for drivers, I would say, because you have to support multiple operating systems, and they're not always, I don't want to say they're license incompatible, but they're not the most friendly to play together. So there's two examples that Intel currently does this to varying degrees of success. There's the graphics driver and the network driver. And I'm not an expert in the network driver, by the way, so if you want to, the guys are right there, if you want to yell at them. But fundamentally, I would say the distinction is for graphics driver, Intel does the Linux open source driver, and it's supposed to be dual licensed. That comes from before the i9-15 driver was part of the Linux kernel. So it was dual licensed, it was out of tree. It got merged in, the dual license was retained. We've tried to keep that up, but hang on to that thought for a second. The Intel network drivers, on the other hand, are a little bit different in that I would say it was less of a community project. So the i9-15 drivers historically was quite a bit of a community project. So initially Intel hired a couple of developers, including Eric Anholt from your community, and they got a lot of support from companies like Red Hat to actually do the drivers. And so there was a lot of sense in kind of working within whatever that community, right? Match the ecosystem. So that community was all GPL. We were all working in that community. On the networking driver side, for Intel, it had all been more of an internally developed thing. And so as they released the code, they were able to say, hey, Linux drivers are GPL, BSD drivers are BSD, Windows drivers are proprietary, like not a big deal. And so what that means is there's sort of some pros and cons, and I don't want to spend too much time on this, but generally if you're looking at opening code, you know, and you think Intel's done a good job on some of these things, please come talk to me, and I'm happy to give you more details if you have questions about how you might want to do it. Okay, so I'm going to go by this pretty quickly too, I think, 11:11. Intel's been contributing, so like I said, I worked on Larrabee in 2008 and we were working on FreeBSD, but there were no contributions. And so I wanted to go back and figure out, like, what has Intel actually done? Like, what kind of reputation do we have here in this community? And this is more or less, I mean, I'll let you guys read it and hopefully the slides will be shared somewhere. But more or less what I found was Jim Harris had done a lot of work on the storage side. We have contact with him. He's no longer working on FreeBSD drivers, but he's still around. There's some dude named Carl, DPDK, and then, I mean, and to be clear, like, so the networking team manager, Sean, gave me all the bullets for their contributions, but you know, networking stuff is all good. And then we had some problems. So prior to this, I would say Intel's efforts were basically, how do we enable the customers that are buying our hardware and do that as minimally as possible and nothing further. And then when we had some of the you know, issues, we started getting a lot of feedback from customers who were kind of upset, and we realized that we needed to kind of have a more concerted effort in trying to get ahead of these things. So making sure that the operating system was as secure as possible before releases, before disclosures to the general public, making sure that our customers who have these large data centers are protected before exploits are in the wild. And so that was when Intel and the FreeBSD Foundation established a partnership, which this happened last year. I think it was on, oh, I didn't put it, that was last year, 2017. So this is a slide that got changed a lot from legal. So, so I'm going to read it a bit with you guys. Yeah, okay. So, you know, in general, we're trying our best to make sure that security is one of the first concerns, and we are here to do our best job to help with that. Now, sometimes that means giving money, sometimes that means engineering resources, sometimes that means communications, getting people in the right conversations, connecting the right people. It doesn't always mean like Scott or myself are doing page table isolation, right? Like there's a lot of fuzzy stuff to this. Yeah, and I think it's going quite well personally. There's definitely a desire on our part to expand as far out as we can in terms of awareness. I mean, there's a cost benefit here. Like, we can't talk to every operating system person ever, but certainly anything that has someone running Intel on it in production is interesting to us. Okay, so this year, we founded a team in OTC, in the Open Source Technology Center, for working on FreeBSD. I officially started on June 1st. I was looking a little bit before then, but I had to wrap up some of my previous duties in my graphics architect role. And so our job number one is being the liaison to the community and supporting any of the mitigations needed for some of the security flaws. Now, as it's turned out, we've had a lot of spare time because Kib has done a lot of the work. And so it became pretty important to figure out what we should do next. So if you just ask around the room, I don't know how many people here were at the FreeBSD Dev Summit where they do the have, need, want, which is really cool. There's a lot of things that people want. There's a lot of things that people need. Sometimes there's things that people have. And it became kind of my first job to figure out what it is that the community wants. I'm going to talk a little bit in a second about how I made these determinations, but it started out with essentially just figuring out what it is that people are asking for. And so my goal, and I guess my technical position is architect, but So I get to say like what we should be doing technically. My goal is to be useful. Like I don't want to come along and just be dead space. If there's stuff we need to do to help with security problems, let's do that. If there's stuff that we need to do to help developer ecosystems, let's do that. If there's stuff that we need to do to deliver product, let's do that. And you notice I used the verb doing. This was a coincidence that just worked out very well. You know, I realize the irony here because I'm talking and I'm not doing, but this is what we'd like. So it turned out to not be so easy. I wanted our team, our relatively small team, to kind of get some wins early on and actually do something. There was definitely a period of figuring out how to do that. Scott and I both were doing Linux development before this, and so it wasn't exactly a short transition to get from being an efficient Linux developer to being an efficient FreeBSD developer. And so there was all the usual stuff you'd expect in the first bullet. And so we actually have had some wins, and I'm gonna spend a second to just call those out. So between the two of us, we've landed 7 somewhat trivial patches in some cases since July, but they're there. We've ported turbostat, which is a tool in the Linux kernel for getting a lot of information about various C states and when you've gone into turbo and so on. We've actually participated, so I led a session in Cambridge on power management. Scott's been doing the NVDIM testing, and I accidentally found a 10-year-old bug when I was doing all that, and Kib fixed it. And again, this is actually coming from someone, this quote is coming from, so it sounds really dumb, right? But this guy's super highly paid, and that's what he told me. Do things people care about. So that's how you get really highly paid. You say things like that. Do things that people care about. So the networking guys are continuing to pump out driver support. This actually was completed, and 100 gigabit I'm sure is coming soon. Scott is working on NVDIM namespace support, which is sort of a way of partitioning NVDIMs. There's a couple of interesting use cases. I don't think anybody in the room had those use cases, but you know, he's learning about the geom layer, getting more acquainted with the code base, which is something that we didn't have. I'm looking at power management, and Eric Joyner over there was given some time to start looking at Thunderbolt 3 support. So there's definitely things we're working on today that I hope will benefit you guys. Okay, so figuring out what to do is real tough, especially when you're resource constrained and you don't have a lot of expertise and you have a lot of people coming at you at once with what they think you should do. And so I try and simplify things whenever possible. They teach engineers like, yeah, it's always simpler than you think, but that's not always true. There's sort of 3 buckets of where I'm getting the list of things that I think we should be doing or that people think we should be doing. And the first is community. That's all of you. Well, I guess that's not all of you, because some of you guys are customers. But community is like yesterday, and I want S4, I want Hibernate support or suspended disk support, right? Somebody somewhere has this use case and it's really important to them and they don't use it in production and it's not for their job, but man, it'd make their life just a little bit better. We have customers who are, you know, the IX systems who are buying Intel product and saying, we really need whatever, you know, 100 gigabit Ethernet working better. And then we have sales and marketing, which is sort of like the prospective customer. They're the guys who, this is Intel sales and marketing, they're the guys who are like, hey, we really think we can sell a lot of product and we need to get people jazzed about whatever, ISAL. And so it needs to work out of the box. And we want you guys to get it working, and we can tell customers, hey, just install FreeBSD 12 and it'll work. And so there's this balance between doing those things, and it's not always so easy even in that. But really, it's even more complicated, in my opinion, because we have a couple of extra Venn circles there. And there's developer interest and there's resources. And so I was told explicitly I can't tell you how many resources we have, but it's not many. And we also, you know, everybody likes to work on certain things. Like, I respect the fact people who like to work on CI systems. I think CI is incredibly important. I think we really need CI on our team, but I don't want to do that. And maybe that becomes priority number 1, but if I don't want to do it, I'm not going to do a very good job. And in addition, so dev interest and resources are added to this. And the point really here is, does the community want it? Does the sales team want us to do it? Is there a developer who's available for it and wants to do it? And are customers actually going to use it? And what's sort of, I don't have this in my slide, but I did actually go through this exercise of taking all these tasks and figuring out like where they lie on this Venn diagram. And what's sort of interesting is almost nothing is in the center. And I don't know if that's true. I've never done that for Linux. So I don't know if that's typically the case, but that was my experience. And so I'm quoting myself here. This is what we do. Okay, this is not complicated stuff. Intel sells silicon. That's how we make revenue. Our job is to make sure that FreeBSD runs really well on Intel silicon. And here's the request so far under a rainbow. So the thing on your left are the things, so I made a blog post when I first started. I said, what do people want? And this is just transcribed basically exactly. And the things on your right, and I guess it's my right too, are things that are kind of in the other bubbles. So things I've heard from potential customers and what our sales team wants to deliver. And so, I mean, the point of this slide really, one is, I hope the slides are shared. I'd like people to look at it afterwards, and if there's anything that they're like, hey, I really want that too, that'd be great. And I have a, call to action slide in a second. But, yeah, it's just, the point of the slides, there's a huge list. And so, I got another Venn diagram here talking about how I personally am prioritizing the work. And hopefully it's fairly self-explanatory, but generally speaking, there's the three buckets. And one is, what kind of impact is this going to have? So, for example, to the S4 thing, sorry to harp on that, whoever wanted that, but if we go and do suspend a disk or hibernate, and there's like 2 developers in the world that are now happy, you haven't really had a big impact. Unless those developers are, the most prolific developers in the world. So maybe like the Kibbs or the Matt Macy's, like maybe that matters. But in general, if you're only helping 2 people, like not such a big cause to prioritize it. And then let's talk about feasibility. So that one should also be straightforward. Is it something we can reasonably do? The work that I'm doing in power management, I thought was more feasible than it is. And so it seemed to actually be something that was relatively feasible. But again, S4, right? Like that's a really big task. And maybe if you've done this for Windows or Linux previously, like you have enough experience to do that. And this is where it kind of maps into the developer's desire to work on that and their experience. But generally, like given our team size, we can't just take on anything. And finally is alliance, and this is, let me see what my next slide is real quick. Finally is alliance, and this is actually for us the most important thing. So I will prioritize anything that has community alliance over anything else. So if there's a project that benefits Intel, which is sort of like the always the case, but if there's work going on that Intel can help, and this really highly paid guy that says do the things people care about, he uses the term skin in the game. Like, do people have skin in the game? And that's the one. If people have tasks that already has an ecosystem of people working on, things that maybe needs that last push, or hey, we really don't know how to debug this Thunderbolt thing because the docs aren't public. Like that's where I want to really help right now, because I think that's where we can have the most bang for the buck, given that we don't quite have expertise in a lot of the subsystems yet. And just grading, like this was just kind of, I thought, interesting, but I tried to sort of grade where the work that we're doing today actually is. And so the work that Scott's doing, or Scott's helping Caustic on right now in NVDIM, I think is the one that meets all of those. There's actually people working on it in the community. It's something we can actually do. It's going to have a lot of impact to customers. So that was cool. And I think Thunderbolt also is pretty good. I think the work that I'm doing is pretty bad. I thought it was more feasible, you know. But the nice thing about power management, and I'll discuss it a little more if I have time, is it really actually does affect pretty much everybody using a machine. People tend to think that power management is only beneficial if you're using a laptop, but typically when you have thermal constraints, if you can save power anywhere, it ends up improving your performance. It should really be called efficiency. So what's the call to action? As I'm getting these tasks, help me prioritize them and help me understand in particular where we can co-invest. So where we have that alliance. I'll say it again, if there is outstanding work that has a community already working on it and it needs like a little help from Intel, whether that be, well, I can't commit money, but whether it's like developer resources or information, like I'm in, just find me. Help me find the new work, right? So like we're getting stuff from sales and marketing, which is cool, but what is it that is missing for you guys to ship your products? What is it that puts you at a disadvantage to say your competition that's running on Linux? Because again, my goal is to make FreeBSD work well on Intel Silicon. And so yeah, if the Venn diagram thing works, if I can get it in the center of that Venn diagram, give me a holler. And power management, so again, I'll get into it in a little bit, but if you have ideas about how runtime power management should work, that's something that's going to affect all hardware, not just Intel. So chime in, help me move that point. And be nice. So far, everybody's been super nice, actually. That's not been a problem. But I'm hoping that we're going to get some more developers coming along. Maybe they're going to ask stupid questions. Try your best to understand that not everybody was born a hardened FreeBSD developer, and yeah, some of us still like Linux. All right, do I have time for this? Oh yeah. All right, so let's talk about power management. Any questions on that, by the way? So I'm gonna kind of diverge into like actual work. So if people want to talk about like sort of the higher level Intel stuff. Okay. So I took on power management again because I thought there's a lot of impact here, and I think there's a lot of impact that people don't realize if I actually can get it working. And so it seemed like a good task because there was a lot of ROI, and a lot of problems end up being power management related. Hello?
Nope.
Hello?
Battery.
Hello?
Or you might have to hand mic on. Your hand was near the remote. You might have to turn it off. Now you can say all the stuff legal didn't approve.
Yeah. Legal approved all the text on this. It's the first presentation I've done that I had to get legal approval. Is this, hello? Okay.
Yep.
Sorry about that. No, I'm not. It wasn't my fault. Okay, so so here were my goals. I think I was talking about why power management is important. Does anybody think it's not? I mean, does anybody, seriously, does anybody think like this is a waste of my time, I shouldn't be doing this, I should be doing something else instead? Okay. I'd be a little upset, but I wouldn't be too mad. So for me, I had no idea how this worked in FreeBSD. I had to go find out, number one. Number two is adding something called Suspend Idle. And this is something that Linux has had for a long time. And bear in mind, if you go back to my timeline of work I've done, I've never really done anything in power management. So when I say Linux has done this, it's like my understanding is Linux has done this. It's called Suspend Idle. I don't know much more than that. The power management guys used to always complain graphics was causing all these wake-ups, and it was never our fault. Suspend Idle is, so I'm going to go through a flow chart in a little bit, but Suspend Idle effectively is saying, hey, maybe I don't trust the platform to actually go into a low power state, so I'm just going to turn off all the devices and then go as idle as I can. And it's sort of like well, I'll get into it a little more later. Next step was something that we're calling emulated S3. And so what that is there's platforms now that are being shipped that don't have S3. And S3 is Suspend RAM for people who are unfamiliar, or just Suspend, or maybe Sleep, is the other name for it. Now there's this technology that Intel invented called S0IX. And so if you go back to my Venn diagram, maybe this becomes a sales and marketing part of a bubble. But S0IX is essentially a way for you to do an S3-like transition, but the hardware does it. So you don't need to go through your reset vector, or whatever they call the resume vector. It just works. And then once I had that all working, the idea was to make a runtime power management framework. And I'll go through the flow chart. You'll understand that a bit better. But the goal would be essentially, whenever the system is idle enough, you'll suspend the idle, and you'll get those really deep package C states, they're called. And then finally, it was going to be to pick up a platform off the shelf and actually make it work. And then say, hey, this works for Intel. If you ARM guys want to make it work, here's the framework. Like, by all means, if you have a device driver that isn't playing really nicely, please fix it. But to actually get it working on a platform, to be able to DPMS your monitor off, and you wake back up and you see, hey, I got these package C states that are pretty nice. And here's where I am. I was really hoping today to be at number 4. I was really hoping for my presentation to be able to present the interface that I wanted for runtime power management. I am unfortunately still debugging a machine, just doing suspend idle. And I put this Albert Einstein quote because it makes me sound smarter. What's happened is, like, that's not actually true. So I'll run my tests, I'll do like 8 successful suspend resume cycles, and 9th time it doesn't work. Or I'll rebase and there'll be no changes underneath, and all of a sudden it doesn't work. So I'm battling some weird stuff, and I think it might be hardware related. But it's, yeah, I'm going a little bit insane. So let's talk about sleep flows real quick. I like making flowcharts because I was an architect for a while. So essentially, this is today what you have for sleep state. So you get some sort of event that says I need to go to sleep, and that might be lid closed, someone presses the sleep button, although I don't know how many, I guess laptops still have sleep buttons with the function keys, huh? Or you press the power button. Now all of these things are actually configurable through sysctls, what the behavior is. So really it could be any number of states that can get you into the S3. But we make a determination based on that. Which one? Is it S5, which is power off? Is it do nothing? Or is it S3? Once we've determined that you actually want to suspend, we go through all the devices and we put them in D3, which is a PCI device power state off, basically. There's some ACPI goop, and then we bring down the CPUs. All the processes are halted, clocks are stopped. We go down to 1 CPU, it gets bound to CPU 0, and it makes the ACPI call. When everything wakes back up, there's this magic that you run through this resume vector. At some point, an event will occur and you'll wake back up, and it basically does everything in the reverse of what I just said, and then you're good to go. So this, for the most part, works for most people today. There's some quirks. Now, when we're doing the emulated S3 thing, it looks really similar, except we're skipping a bunch of stuff. And again, this is kind of where I'm debugging today. But instead of doing the ACPI crap and bringing down the CPUs and restoring CPUs and doing the ACPI wake, after you bring down all the devices, you just idle the CPU. And you get to S0IX if you use a specific M weight at the highest C state you're allowed on the CPU. But effectively, it's all the same after that. You get an event, you wake up the devices, you go back to business. And this is where I'm currently stuck. So I have a case now where I have these events that are waking me up, and as far as I can tell, they're nothing. So figuring out how to, there's some resiliency you need to build in there. And then we're going to get into, this is what the runtime power management framework will enable, and it's called, well, I'm not sure if it's officially called Opportunistic Idle anywhere, but it's Opportunistic Idle. So you've found the system to be idle enough, let's try and actually get those low power states. And so what you have there is all of your devices go idle. You've made some determination like they've been idle for long enough, or the last one just went idle a second ago, that's long enough. And LPI is short for low power idle. Do we want to actually try and get into our low power idle state? Maybe it's too early, let's try again. Get the CPUs down, and otherwise it follows the same path. And I was just talking with John a minute ago about kind of how you figure this out. Like, do you bring up a device just long enough to service this interrupt and go back, or does that wake up the system until the next time you bring down all the devices, or how should that work? But this is where I'm getting to. This is what I'd really like to make work. Some of the questions that we have right now. And so this is where we are. I was kind of describing. Currently in Suspend Idle, these are the 3 problems I'm having. In the order of frequency, so random wake-ups, I have a single platform that I get this fairly frequently on. Random power off is, I have no idea what's causing it. At some point init decides to shut off my machine after doing this several cycles, and then just dead. So that actually means like the power button isn't waking me up. And again, these are like the Albert Einstein thing. Like I can't reliably reproduce any of these things. The other thing that's really tricky is one of my wants is I have no way to remotely work on these platforms, because if you're not actually there to press the power button, you can't bring them back up. So RTC interface would be really nice. I have been thinking about runtime PM actually since I started this, so I had kind of drafted some words about how it should work, but I'm not there yet. And so the wish list interface are things that I've already talked about. I'm having a lot of problems with NVMe, to be honest, getting a lot of errors. And the other thing that I ran into was this one. So as you're bringing devices down, like there's nothing left to print. So if you start getting assertions or problems in between, you're dead. You don't get any of those messages. And so I was thinking maybe it would make sense to kind of I don't know, in the print path somewhere or somewhere to determine, hey, the devices are actually down. Maybe I should wake things up enough to print. I don't know if people have opinions on that, but I think that would be really useful. John also pointed out to me, you'll get it in the message buff later, so you could get it out of dmessage, but not if you're in an insertion. Okay, I think that was all I had. A couple of thanks. I want to really call out John Baldwin, who's fielded a bunch of questions from me. And Ed, who's also taken a bunch of questions from me. They've been tremendously helpful. And then some of the Intel folks who've given me information for the slides, and John Venn, because I used a lot of his diagrams. And here's, if you want to actually get at anything or contact me. I mean, if there's stuff like, just, you don't want to waste my time, I get it, like you feel bad or whatever, but if there's something that you think might potentially be interesting, just reach out and let me know. I think that's it. So any questions? Answers? Oh, we got one.
Is this on? So when you were trying to figure out how to switch from being a Linux developer to a FreeBSD developer, other than drinking a lot of bleach, did you take notes on the differences? Because it'd be very interesting if we had a way to explain to other Linux developers what it might take to do that.
I had the best intentions to do that.
I appreciate your best intentions.
Yeah. No, well, and it was for my sake, right? Because I'm hoping to get some more engineers on our team, and I didn't.
Okay.
I didn't. I think that would be a wonderful thing.
I'll pick your brain at lunch.
What's that?
I'll pick your brain at lunch.
Yeah, it would be a wonderful thing to do collaboratively, I think. Oh, that's the one other thing I wanted to mention. I can't stay tonight or tomorrow, so if anybody wants to chat with me, like, just come get me. And if you want to pull me out, that's fine. I'll be around all day today, but I won't be around past that.
Thanks.
Yeah, thank you.
So it sounds like it's pretty orthogonal to what you're actually doing, but power monitoring, I mean, you know, that's sort of a big deal in iOS is sort of metrics. I mean, and I understand Linux has power top. I mean, I don't know anything about it. I mean, I'm told it's janky, but do you have any thoughts about that? I mean, I understand like adaptively reducing timeouts and whatnot and gathering information about well-behaved apps. I mean, I see JavaScript is like a massive offender whenever I'm running Firefox, and Slack seems to be pulling every millisecond. But any thoughts on just, I mean, that seems like it's more targeted towards laptops, and so maybe less impactful, I mean, than keeping your server from like burning up your data center. But
well, you know, you don't know until you know, right? I mean, someone runs PowerTop on some server somewhere, and all of a sudden they see their, I don't know, let's say they have some wacky audio device in there for some reason, and it's generating interrupts even though it's not on. Like, I couldn't say whether or not it wouldn't be useful, but yes, generally more for client. And I think PowerTop is quite interesting. I think it's done a lot for Linux, actually, and I think it started out as sort of this, it was a project by the person who I was quoting earlier about do things people care about, actually. And it sort of morphed into something that became a way, like they have this auto-tune in PowerTop, and you basically just hit a button and it tweaks all your tunables to what's optimal. And you can argue, well, if those are the optimal tunables, then why aren't they the default? And you get into a whole other argument. But the reason we did turbostat, actually, was I went and talked to the power management folks who sit near me, and I said, if we want to actually be able to kind of figure out what residencies we're getting in the various C states and package C states, what should we be doing? Like, should we port PowerTop? And they all said, hands down, get turbostat working. So if I had more time, I think something like PowerTop would be great. To answer your question.
Okay, and is there anything more that needs to be done on the kernel side for PowerTop? And what's the issue there? Is it just the fact that it's Linux-specific ioctals, or is it there actually?
Yes, sysfs. I think missing bits in sysfs, but I haven't looked very closly.
Okay. I think so. Is there anything else that any other sort of tooling that would be relevant to making? I mean, like we have we have the equivalent to from kind of. I mean, is there anything else that would be helping sort of tuning FreeBSD to be better behave with respect to power consumption?
I'll get back to you when I find it. I don't know.
Yeah, that's fine, thanks.
Yeah. Okay. Well, I'll be done if nobody else has any questions. Again, please come find me. I am more than happy to spend some time talking with anybody. Thank you.